You usually think of your digital life as something entirely weightless. It is this illusion we have all kind of bought into. You open up your laptop, you type a complex, maybe even sensitive question into a frontier AI model, you hit enter, and the answer just magically appears on your screen.
Right. It feels completely intimate.
Yeah, exactly. Like a private conversation happening right there locally, just at your fingertips.
I mean, it really feels like the intelligence lives inside the glass of your monitor. You don't see the gears turning.
But the reality is actually radically different. Every single prompt you type, every late night question or proprietary business strategy you feed into that AI is actually being beamed out of your house or your office.
Out into the ether, yeah.
Right. It travels hundreds of miles to a hyperscaler. I mean, we are talking about a mega corporation running an industrial data center the size of a small city.
Oh, absolutely massive facility.
Yeah, and your private thought is processed on their silicon using a trillion parameter model that requires cooling towers and, enough electricity to power a neighborhood just to send a few lines of text back to you.
Which kind of shatters that illusion of intimacy when you think about it.
It really does. Suddenly, it doesn't feel so intimate at all. It feels more like you are shouting your personal thoughts through a megaphone in the middle of a crowded warehouse.
That is a great way to put it. And that illusion is masking a massive vulnerability. We're entirely dependent on these institutional hubs for our daily cognitive work right now.
And if you have been wondering where your AI prompts actually go, who is looking at them, and whether this centralized system is just, well, how things will be forever, we have got the answers for you today. Welcome to the deep dive.
It is a great topic to dig into today.
The mission today is to figure out the future of AI by looking backward. We are unpacking a really fascinating July 2026 article from Tech Reader magazine by Aaron Rose, and it is titled "The Compute Always Comes Home."
The central argument Rose makes here is just super compelling. He posits that the massive centralized AI architecture we currently rely on is not the end of history.
Right, it is not permanent.
Exactly. It is merely a transitional phase. We are just passing through this era.
Okay, let's unpack this, because right now we all kind of assume this giant cloud infrastructure is permanent. I mean, we see these tech behemoths building billion-dollar server farms, and we just accept that we will rent our intelligence from them forever.
It feels inevitable when you look at the scale of their investments, for sure.
Yeah. But to set the stakes, let's look at the modern anxiety surrounding this. Alex Karp, the CEO of Palantir, recently crystallized this paranoia. He posted 3 questions on X that every serious business leader is suddenly asking.
And those questions are really getting to the heart of the issue.
They are. The questions are, who owns the data? Are the prompts secure? And is this being transferred to you?
You know, those sound like very cutting-edge critiques of the 2026 AI landscape. The anxiety over feeding proprietary data into a black box is totally peaking right now.
Oh, for sure. Everyone is worried about it.
But the historical irony here is that those 3 questions are actually 70 years old.
Wait, 70 years old? Really?
Yeah, seriously. Serious operators asked those exact same questions about mainframes, time-sharing systems, and early cloud infrastructure decades before artificial intelligence was even a commercial reality.
I have a really hard time wrapping my head around that. I mean, 70 years ago, we didn't even have the cloud. We barely even had computers.
Well, we had institutions with computers. That is the key difference. Whenever compute lives somewhere other than with the person generating the work, these specific anxieties just naturally flare up.
Ah, I see.
Before the personal computer existed, there was literally no such thing as private compute. If you needed to run a complex calculation or process data in the 1960s, you couldn't do it at your desk.
Right, you couldn't just open a laptop.
No, you had to go to university, or a massive corporation, or a government agency that owned a mainframe.
It is like deciding between taking a taxi and owning a car. Right now, using a frontier AI is, it's like taking a high-speed, incredibly luxurious taxi. It gets you exactly where you want to go, and faster than you could ever drive yourself.
But you don't own the car.
Exactly. You don't own the car, you don't control where the driver goes next, and you definitely don't know who is getting in the backseat after you or if the taxi company is keeping a permanent log of every destination you have ever visited.
The mainframe era operated on that exact same taxi model. You submitted your job, often literally handing a physical stack of punch cards to an operator.
Wow, punch cards.
Yeah, punch cards.
Yeah.
You waited, and eventually, maybe hours or days later, you got your results back. The hardware was theirs, the management of the data was theirs.
So privacy wasn't even a consideration.
Privacy was a total non-issue because the entire paradigm assumed that computing power was inherently institutional. It wasn't meant for individuals.
But let me challenge this framing a bit. Because looking back from 2026, it is incredibly easy to say, oh, obviously personal computers were going to take over. But back in the 60s and 70s, the smartest engineers on the planet didn't view mainframes as a stepping stone, did they?
No, not at all.
They thought giant centralized mainframes were the permanent, most rational way to organize computing.
The prevailing wisdom of the time absolutely supported centralized computing as the end state. And honestly, we shouldn't judge them too harshly for that.
Why not? I mean, they were wrong.
They were, but by 1970, large-scale centralized computing was objectively the most rational, economically viable way to do things.
Yeah.
The hardware was astronomically expensive.
Right, they didn't have cheap microchips.
Exactly. We were just transitioning from vacuum tubes to early transistors, and the machines took up entire floors of buildings. Furthermore, the expertise required to simply keep the machines running without them literally catching fire was incredibly scarce.
You needed a whole team just to keep the lights on.
You needed a priesthood of specialized engineers, yeah.
So the economics of shared access were undeniable back then. I mean, why would a single person want a computer when it costs $1 million and requires an engineering degree just to turn the thing on?
Right. The arguments against personal computing were serious, and they were made in good faith. Industry leaders argued that individual machines would just be redundant. They would sit idle most of the day. They would be impossible for a layman to maintain. And frankly, they would be far less powerful than what a shared facility could offer.
That sounds suspiciously identical to the argument people make today about why we need hyperscaler data centers for AI.
It really is the exact same argument.
You hear it all the time. People say, why run a tiny, weak model on your laptop when you can access a trillion-parameter model in the cloud?
The parallels are striking. The experts in 1970 were entirely accurate, given the technology and material science that existed in 1970. What they failed to anticipate was the sheer velocity of the shift in cost curves.
They completely missed Moore's law, right?
Exactly. They drastically underestimated Moore's law. The realization that the number of transistors on a microchip would double roughly every 2 years, driving costs down and computational power up at an exponential rate.
It is crazy how fast that happened.
They just didn't foresee how rapidly miniaturization would accelerate, making individual ownership not just financially possible, but highly preferable.
This perfectly sets up the core historical pattern the article identifies, the inevitable arc of computing. Because when the personal computer finally became viable in the late 70s and 80s, that entire institutional assumption just collapsed almost overnight.
The speed of the transition was breathtaking. Within a single generation, compute migrated from the institution to the individual. Data that used to live exclusively in centralized climate-controlled systems just moved to desks in people's homes.
And then it moved to laptops.
And then it moved to smartphones in our pockets.
And according to the source material, this isn't just a one-time fluke with the PC. It is a relentless, repeating cycle in the tech industry. Mainframes gave way to personal computers. Time-sharing systems, where you rented time on a bigger computer, gave way to local software.
Yep, the shift is constant.
We saw enterprise software shift into SaaS, or software as a service, moving things back to the browser for a bit. But even then, we didn't stay fully centralized. Carrier-controlled mobile networks shifted to smartphones, where users had open, locally run app ecosystems. The compute is always, relentlessly moving from the center out to the edge.
If we connect this to the bigger picture, this pattern is so deeply ingrained in the history of the industry that it functions practically as a law of physics for technology, rather than just a mere market trend.
A law of physics, I like that.
Compute always gravitates toward the individual. Data naturally moves toward the owner. Control inevitably moves toward the user.
What I find so fascinating about this is the total lack of centralized planning. Nobody forced the PC revolution to happen. There wasn't some government mandate declaring that individuals deserve their own microprocessors.
Right. There was no master plan.
The technology simply advanced to a point where centralization was no longer a strict requirement, and the economics just followed human desire.
That is a vital takeaway for you as the listener. We tend to mythologize technological shifts as being driven by visionary manifestos or really clever marketing. In reality, these massive questions about data ownership, privacy, and security are rarely answered through policy debates.
They are answered by the tech itself.
They're answered through raw capability. The personal computer didn't win because someone wrote a brilliant philosophical essay proving that mainframes were evil.
It won because suddenly you just didn't need the mainframe anymore. The technology made centralization totally unnecessary for the vast majority of daily tasks, like word processing or spreadsheets. You could own the capability outright instead of paying a toll to rent access to it.
Capability always dictates architecture.
Here's where it gets really interesting. Because if we take this historical lens, this law of computing, and lay it over our current moment in July 2026, it paints a very specific, predictive picture of where AI is heading next.
The article makes a bold claim here. Right now, in 2026, we are essentially living in the early 1970s of AI.
The early 70s of AI. So we are basically in the mainframe era all over again. That makes so much sense.
It perfectly describes the current landscape.
Right now, to run frontier AI, the absolute cutting-edge models that can reason across multiple domains, you need infrastructure that no individual or normal enterprise could ever afford to own. You're talking about hyperscalers needing football field-sized data centers. But why do they need to be so big anyway?
Well, it is because of the underlying mechanics of how these specific models operate. A trillion-parameter model is essentially a massive probabilistic engine.
Okay, what does that mean in plain English?
Every time you ask it a question, it is performing billions of complex mathematical operations, specifically matrix multiplications, in parallel, simultaneously.
Billions of them, just for one prompt.
Just for one prompt. To achieve that without making you wait an hour for an answer, you need thousands of highly specialized silicon chips working in perfect tandem, and they consume massive amounts of power.
So just like the 1970s mainframe era, the centralized AI arrangement we have today isn't some malicious conspiracy by big tech to steal our data. It is actually totally rational. The hyperscalers just built what the technology currently demands at the scale the market requires.
Exactly. They solved a massive infrastructure problem, and the result is a utility that is genuinely useful to hundreds of millions of people.
I understand the historical parallel, but I have to play devil's advocate here for a second. I'm looking at my laptop right now, which is incredibly thin and runs on a battery. And then I'm thinking about a hyperscaler data center that uses enough electricity to power the entire city of Seattle.
It is a stark contrast, for sure.
If these frontier AI models require that much raw juice to operate, how can a local device ever compete? Isn't the physical gap just inherently too wide? Won't the cloud always be fundamentally smarter?
That skepticism is entirely warranted. And honestly, it mirrors the exact skepticism mainframe engineers aimed at early PC hobbyists.
Yeah.
But the article points to specific, undeniable technical signals that the arc is already bending.
What kind of signals?
Local models, meaning AI that runs entirely on your own consumer hardware, are improving at a rate that is vastly outpacing forecasts from even 2 years ago.
But how is that technically possible? How does a laptop chip compete with a giant server farm?
Through a combination of extreme optimization and a fundamental shift in how we build models. One major mechanism is called quantization.
Wait, explain that. Is that like compressing a massive high-resolution photo so it fits into an email attachment?
That is a really decent analogy, actually. In AI terms, quantization involves taking the massive complex numbers that a model uses to make decisions, numbers with many, many decimal places, and rounding them off so they require significantly less memory.
Oh, so just making the math simpler so the computer doesn't have to work as hard.
Exactly. What researchers discovered is that you can dramatically strip down the precision of these numbers, shrinking the model's physical footprint, without severely degrading its actual intelligence or output.
So they are making the brains physically smaller and vastly more efficient.
Additionally, the industry is pivoting toward SLMs, small language models. We're realizing that a highly capable AI doesn't need to know the entire history of the Roman Empire if its only job is to help you write Python code or analyze your personal financial spreadsheets.
Right, it doesn't need to be a trivia master.
By training highly specialized, smaller models, the compute required drops by orders of magnitude. The gap between what requires a massive data center and what you can run locally on your own silicon is narrowing with every single hardware generation.
We are seeing edge inference, which means the actual processing of the AI workload happens directly on your physical device rather than the cloud moving from a niche research project into a massive commercial reality.
But we do need to be careful with this projection. The mainframe didn't just vanish when the PC arrived. It evolved into enterprise back-end infrastructure.
Right, the cloud is still huge today for databases and hosting.
Exactly. Similarly, the hyperscalers aren't going extinct. They will almost certainly continue to host frontier capabilities, the absolute boundary of what is technically possible, things like massive drug discovery or global climate modeling.
But for the daily work drafting emails, analyzing our own business data, summarizing meetings, the vast majority of what we actually need AI to do is moving to the device. The cost of capable on-device AI is falling along that exact same exponential curve that made the PC inevitable.
The friction of centralization is resolving in the direction it always resolves outward, to the edge.
This brings us to a crucial concept the article introduces, which is private compute. We hear the word privacy thrown around a lot, usually regarding cookies or tracking ads. But in 2026, the article says we need to be very precise about what private compute actually means in the age of AI.
In this context, private compute is an architectural guarantee. It means that inference, the actual cognitive processing where the AI weighs your prompt against its training to generate an output, happens exclusively on hardware you physically control.
So it never leaves my laptop or my company's server.
Never. It occurs in an environment you govern. Your data and your prompts never transit through an API, they never hit a network cable, and they never interact with infrastructure owned by a third party.
So what does this all mean for you, practically speaking? Sending your sensitive, critical business prompts to a centralized cloud AI right now is a bit like deciding to draft your company's secret, highly classified business plan on a whiteboard in the middle of a crowded public coffee shop.
And to make matters worse, in that coffee shop, the barista is actively writing down your business plan to help other customers start their own competing businesses.
Right. I mean, sure, you get the work done. The coffee shop provides a great whiteboard, nice markers, and the service is incredibly fast. But the sheer exposure of your operational thinking is a massive vulnerability.
It is a huge risk.
Or, to look at it another way, using cloud AI is like using a shared library book where everyone can see your notes in the margins, whereas local AI is like having a private tutor who only remembers what you teach them and never speaks to anyone else.
Both analogies highlight the core issue perfectly. Moving away from that public whiteboard isn't primarily driven by a paranoid desire for privacy. It is fundamentally a capability argument.
Wait, how is privacy a capability? That sounds like a bit of a paradox.
It comes down to what the article calls the cognitive loop. When your AI inference is truly private, entirely new workflows become possible. Your proprietary data, which is arguably your most valuable asset, can be utilized for deep, continuous AI analysis without ever leaving your secure server room or your laptop.
So you can unleash the AI on everything without worrying.
Exactly. Furthermore, your prompts themselves are protected.
Which is critical because the way you prompt an AI actually reveals everything about your current strategy. Like, if I am a supply chain manager and I ask an AI to find alternative shipping routes because my primary supplier in Taiwan just went offline, I have just broadcasted a massive corporate vulnerability.
Precisely. Your prompts contain your most sensitive operational thinking. In a centralized model, that thinking just sits in a log file on a hyperscaler server.
Just waiting to be analyzed or leaked.
But even more importantly, with private compute, your outputs and interactions cannot be absorbed into the training data of a general-purpose model that your competitors can access. The competitive advantage, the localized cognitive loop, stays entirely inside your walls because the compute itself stays inside your walls.
That is huge, because the reality of the current centralized model is that every time we use a cloud AI to solve a hard problem, we are essentially performing free labor to make the system smarter for everyone else, including our direct rivals.
Which is why we're seeing a massive shift in regulated industries. For finance, healthcare, and defense, private compute is no longer just a nice-to-have preference. It is rapidly becoming a strict legal and compliance requirement.
I can imagine a hospital wouldn't want patient data going to a cloud AI.
A hospital processing diagnostic imagery or a hedge fund evaluating proprietary trading signals through an AI system, they cannot legally, ethically, or strategically afford to let that cognitive work happen on rented, centralized infrastructure. They must own their intelligence outright.
So we are marching toward this inevitable future where the compute comes home. But I think one of the most reassuring takeaways from this entire deep dive is that this transition doesn't require us to view the big cloud providers as villains or data thieves.
Not at all. The current arrangement isn't some malicious plot to hoard the world's information. It is simply an accurate reflection of where the economics, the physics, and the technology happen to be for the last few years.
They just built what they could.
The cloud providers built the only architecture that was mathematically possible at the time.
But human nature drives the next step. The article powerfully concludes that when we are given a choice between rented access and owned capability, assuming the cost and performance are relatively comparable, we will always choose ownership.
We always have.
We chose it with personal computers in the 80s. We chose it with local storage in the 90s. We chose it with smartphones in the 2000s. We naturally crave control, privacy, and independence over their digital lives. It is not a political ideology. It is just human nature.
The transition transforms the location of inference from being a rigid technical constraint into a personal choice. And historically, human desire dictates that the compute always comes home.
It really does. Well, before we wrap up, I want to leave you, our listener, with a final provocative thought to chew on, something that builds on everything we have just discussed.
Let's hear it.
If this law of computing holds true, and the compute always comes home, that means we are all inevitably going to end up with our own highly capable, entirely private AI models. Models that live on our devices, that learn exclusively from our own personal data, our own habits, and our own isolated worldview.
A truly personalized cognitive engine, tailored to an audience of one.
But if that happens, do we risk creating the ultimate impenetrable cognitive echo chambers? Right now, despite its flaws, a centralized AI model provides a sort of baseline consensus of reality. But if our local AIs no longer share that centralized baseline, if they are only tuned to agree with us and our specific data, how will our machines, and by extension, how will we even communicate with each other in the future?
That is a profound dilemma. If our artificial intelligence becomes entirely localized, does our shared human reality begin to fragment?
We started today talking about that uncomfortable feeling of shouting through a megaphone in a crowded warehouse when you use cloud AI. But the opposite extreme might be just as daunting, sitting perfectly alone in a soundproof room, talking to an intelligence that only knows how to tell you exactly what you want to hear. It is a fascinating and slightly terrifying frontier.
It will be the defining challenge of the next decade of computing, without a doubt.
Well, that is all the time we have for today's deep dive. Thank you so much for joining us and exploring the hidden architecture of our technological future. Keep questioning the tools you use, keep your compute close, and we will see you next time.